Hello, and welcome to my class, Advanced Python for Beginners. This lecture is aimed at people who are already quite proficient in programming, but maybe not Python's unique features specifically. Let's get right into the topic of today's lecture. Python is a silly language, full of duality. While most of Python's unique features are useful in making great code, they can sometimes be used for more nefarious purposes. While there is a category of features you should probably be using at all times, like type annotations and the if name equals main idiom, there's another category I'd like to talk about today, which I'm referring to as grotesque one-liner temptations. These are incredibly powerful tools in the right circumstances, but they often tempt the more novice Python experts into writing stylistically poor code. Among these are list comprehensions and generator expressions, midline ternary expressions, and container unpacking. Let's look at a basic coding problem and see how some of these features can be utilized. FizzBuzz. So, I've asked ChatGPT to solve FizzBuzz for me, and this is what it gave me. Pretty simple, honestly. It just goes through a predefined range and prints out the relevant thing based on the divisibility of the given number. It's so simple, in fact, it's kind of boring, honestly. I hear you say, this solution isn't unique to Python at all. How can we take the cutting-edge features of Python and make it better? And to that, I say, better is subjective. Behold, the duality of Python, where these features are used for both good and evil. Yeah, let's just get right into it, I guess. So yeah, this version utilizes basic input handling via the sys module as opposed to a hard-coded value, which in this case was 20. You've been in enough programming classes at this point to understand why more adaptable code is a good thing, so let's move on to the next thing. Type annotations are used in the function, which makes it more readable and maintainable, particularly for someone who has never seen the code before. However, it is worth noting that while you should probably be using type annotations wherever you can, they do not change the fact that Python is a dynamically typed language. While your IDE might help you out with some error highlighting if you pass an object of the wrong type to a function, type annotations are not strictly enforced. If you want that, you should be looking at manual type checking via the isInstance function or static type checking libraries like MyPy. Next up, the if name equals main idiom is used here, which is an absolute must in keeping proper code modularity and preventing other files from accidentally running this code on import when they don't intend to. Surely you were already taught this in Prog 1, but since it is a Python unique feature, it's worth mentioning here. What's worth talking more in detail about, however, is the concept of list comprehensions and generator expressions. Let's say we want to compute a bunch of squares and put them into a list. You could do this with a for loop, pushing back new elements with each iteration, and many languages would very well have you do it this way. In Python, though, you can simplify this process to one line, which is not only more concise, it's also faster. This is because list comprehensions are seriously well optimized in Python. Fun fact, they're actually implemented in C. Unlike the traditional approach, which requires repeated calls to the append function over and over again. We can extend this concept to generator expressions, which are super useful in situations where you really just want to iterate over each element and do something trivial with it. In the case of FizzBuzz, this means passing an argument to print for a given integer value. This is especially convenient with unpacking. Let's talk about how we can unpack the elements of a generator expression and pass them into a function. Unpacking involves taking each element of a container, like a list, tuple, generator, set, basically whatever, honestly, and passes each element as an argument to a function. In this example, you can see how passing in a list and unpacking it can, once again, result in some very concise code. Particularly in this instance, printing out all these numbers separated by commas using the traditional for loop approach is a huge pain because of that last element. In every single iteration, you'd have to check if that element is the last one and avoid printing a comma if it is. The generator approach vastly simplifies this by just specifying a separator character to the print function, which saves on unnecessary computations and is more readable to boot. Well, that's all great then. As we can see, Python allows for various optimizations that somehow boost conciseness, readability, and even performance simultaneously. But I hear you saying, these optimizations are powerful in isolation, sure, but what happens if we combine all these Pythonic elements together in our function? What does the superior function look like? Right. So you've already seen it, but it's this. This is what the superior function looks like, apparently. Here, we've got a totally unreadable mess. Putting aside the usage of binary and hex literals for seemingly no reason, we're going through the range of 1 to n plus 1. We then condense an if statement and 3 else clauses into the same line, and this is our FizzBuzz logic, returning the appropriate string for that value of I. These strings are then placed into a generator expression, which is promptly unpacked and passed as an argument to print. The problem with this, of course, is that there's just way too much going on. Good code usually involves one logical step at a time. Here, we have 4 based on the ternary operators alone, 5 if you add the generator expression, 6 if you count the unpacking, and 7 if you count the call to print. So, here's what we're going to do. We're going to break this all up, take out any unnecessary steps, and see just what we're left with. All right? Okay, so we're going through the range. We're printing the appropriate string based on the divisibility of the number. Wait a second. Is it just me, or is it possible we've seen this exact code somewhere before? Right, ChatGPT. The AI response for the simplest FizzBuzz solution I could possibly ask for beat my ingenious Pythonic one. The moral of the story here is that while Python offers us some really powerful tools like list comprehensions, generator expressions, container unpacking, and more, we shouldn't be overzealous in how we use them. Sometimes the basic solution just works better. And that concludes my lecture for today. I hope you enjoyed, and I thank you very much for your attention.